Good morning, everybody. Welcome to NTWC Plus. The date is September the 25th. We're making our way through the peak of the hurricane season, and things have come alive, and we're going to talk a lot about that during the course of the program today. And it's a great program, I think. Dr. Matthieu Le Henaff is with us today. We're going to get to him in just a second. First, I want to thank our sponsors who make these programs a reality week in and week out. We start with the USAA. Thanks, USAA, to make this possible for us and have been doing it from the very beginning, and we appreciate that. The South Padre Island Convention and Visitors Bureau, the host of the National Tropical Weather Conference in-person conference, will be there the first week of April in 2025, and we encourage you to go online soon and submit your registration. Once that registration opens up, be one of the first to get in. We also want to thank the Weather Company, Weather Boy, and Weather Call, all folks that make NTWC Plus a possibility. Bill Reed's not with us today. Bill is out gallivanting somewhere. I think he's in New Mexico this week, enjoying some time away and enjoying some lower humidity. I think that was his key. And Dr. Hal Needham is not enjoying lower humidity. He's right on the water somewhere. Good morning, Dr. Hal. How are you?
Good morning, Tim. I'm on the ground here in Tampa, where we're expecting some wind, some big-time wind and surge impacts tomorrow.
I think, as I said before we started, you put an X on the sidewalk where you're standing and see if you can find it again tomorrow afternoon, see if it's there. Who knows, right?
Yeah, that's it. I mean, the big story here is going to be the surge, I think, with the huge wind field. We're expecting 5 to 8 feet of storm surge. Pinellas County, Hillsborough, this area here already has a mandatory evacuation for Zone A in the storm surge zone, and people in mobile homes as well.
We're going to get into the tropical update a little bit later on, but I do want to ask you before we get to the program today. You flew in there last night, and you commented on what people were saying on the plane and the airport, and as they get ready or don't get ready for the storm. What do you see?
Yeah, unfortunately, the overhearing 2 hours of plane conversations about hurricanes was pretty much what I expected. West Central Florida is one of my biggest areas of concern because they've had so many near misses in recent decades. I heard people talking about why the hurricanes always miss. The ancient Indian burial grounds always comes up, and people say, oh, this storm's going to miss us to the west. People focusing on the cone, focusing on the category. I did not hear one person talk about the huge wind field or the storm surge threat here in places like Hillsborough and Pinellas County.
That's absolutely amazing. Absolutely amazing. Well, we'll do our part, and we've got it. It has strengthened to a Category 1 hurricane, by the way. That advisory just came in, so we'll talk more about that in a little bit. So it is now a hurricane as it heads in your direction. So that we'll get their attention. We'll talk about that with our tropical update in just a little bit. Thanks, Hal. And I know you're going to have some great questions for our guest today. But let me take a moment and introduce our guest. Dr. Matthieu Le Henaff. I hope I pronounced that right. Glad to have you with us this morning. Dr. Matthieu is an oceanographer in the Physical Oceanography Division of NOAA's Atlantic Oceanographic and Meteorological Laboratory. We all know that as AOML, affectionately. His primary research interest is to improve our understanding of how regional ocean dynamical processes affect the other components of the Earth system and how they can be better characterized and predicted. And there's a lot more I can say, but I'd rather get right to it. And welcome you to the program. Good morning, sir.
Good morning, Tim. Good morning, everyone. Thank you for having me today.
We're glad to have you here. You are in Florida, is that right? But not the same place as Hal.
Exactly. I'm at AOML in Miami.
Well, let's talk about let's do an overview first. Talk about what you do, because it's a pretty lengthy and significant biography. So I kind of want to get an overview. Talk about your job in general, what you do there.
So I am a physical oceanographer. I have training in ocean modeling and data assimilation. So I have interest in both the computer part and how we observe the ocean and how we integrate observations into models to make a forecast or realistic representation of the ocean. And that is also used to assess the impact of observations on our estimate of the ocean. And that's with this background that I first did my PhD back in France, and I studied regional circulation there. And then I moved to Florida 15 years ago. I did my postdoc and started studying the Gulf of Mexico and with the dynamical processes happening there. And then the oil spill happened, so we looked at how the ocean influenced the oil spill, and I also looked at the larger scale with the Caribbean Sea, the Atlantic, and since I joined AOMN in 2015, shortly after I started looking at how ocean observations impact hurricanes and hurricane forecasts, how we can make better forecasts by deploying and assimilating ocean observations into the ocean models that are used for hurricane forecasts. So that's what I'm doing now. I'm involved in ocean observation gathering with the Ocean Glider fleet of NOAA AOML, and I am involved in the assessment of the impact of ocean observations on our estimate of the ocean and how this translates into hurricane forecasting, in a nutshell.
In a nutshell, that's fascinating. And I'm going to let Dr. Hal jump in because I know how you're going to have 1,000 questions, and I'm just going to watch you guys for a while, but I've got a few as well. So Hal, jump in on this.
Yeah, I have so many questions for Dr. Matthieu, and the timing of all this is perfect. There's been a lot this week talked about the oceanic heat content and different physical oceanography characteristics ahead of Hurricane Helene. I wanted to ask Dr. Matthieu, when you mentioned building these ocean dynamical models, I'd imagine remote sensing is a huge part of that through satellites, but you mentioned the glider fleet. Could you talk about some of these innovations using gliders, using drones, these other technologies, both above and below the water, that are helping us model the ocean better?
So thanks, Hal. So the gliders are deployed in areas where there are few measurement of the vertical structure of the ocean, because the vertical structure of the ocean has a very important impact on how the ocean interacts with hurricanes. And remote sensing, as you mentioned, is an essential component, but it doesn't provide the whole information. We need to observe below the surface to know how thick the layer of warm water is, or what is the density evolution, because if you have a very strong contrast in density, then the mixing is more difficult and it affects the way the ocean will feed back onto the atmosphere. So the gliders are there to complement remote sensing, and the global network of Argo floats they are deployed along the coast and in coastal areas to have a better representation of the 3D structure of the ocean in areas that might be close to impact when a storm comes. So yeah, they are an essential component. And I saw you just showed the sail drones, which are also unmanned systems that are at the surface of the ocean that can measure both the lower atmosphere at the surface of the ocean and just below it. And those instruments are essential to measure extreme conditions that would not be possible to observe with like traditional methods. Like you cannot send a ship with a crew in the middle of a storm like that, but those tools are essential to give us information about the air-sea interactions in such extreme conditions. And these measurements will help refine the models to better represent these extreme conditions, because the models we are using now, they were developed for the lack of a better word, normal conditions, but the parameterization that are involved, they need to be characterized in these very extreme conditions to do a better job in representing what really is going on.
Dr. Matthieu, you mentioned collecting data at and below the sea surface. Are the gliders actually in the water or under the water? I mean, how do you get those data from near and below water?
So the gliders, they are ocean gliders. So I'm using gliders because I'm so used, but yeah, they are ocean gliders, so they are inside the water. And what they do is, by changing their buoyancy, they go up and down the water column, and we can also guide them towards a certain direction. And by going up and down the water, they measure temperature and salinity, the vertical profiles of temperature and salinity. And once they surface, every dive they come back to the surface, and then they send their data through satellite, and that's how we get the data in real time.
Dr. Matthieu, how deep can these gliders go beneath the surface of the water?
So we send them to 1,000 meters for monitoring the large upper ocean. But when the storm comes and the gliders are on the predicted path of a storm, then we let them static, and they go to 500 meters, not 1,000 meters, so that they can profile more often, and we have a higher frequency of measurements to better, more finely characterize the evolution of the ocean.
You know, we often hear about sea surface temperature in relation to hurricane strengthening potential. This week, Brian McNulty from University of Miami in South Florida was mentioning oceanic heat content, really, which I understand, like getting at not just what the surface of the surface water temperature is, but understanding what's going on beneath the surface. Could you explain how gliders and other technologies are used to measure and understand oceanic heat content, and even define for us what oceanic heat content is?
So the heat content represents the amount of heat that is in the upper ocean. That's really the volume of waters that are over 26 degrees Celsius. So like I mentioned, if we measure only by satellite, we have the sea surface temperature, but with ocean profilers, typically gliders, Argo floats, or profilers deployed by the airplanes that NOAA sends ahead of a storm. They also can do that. So they tell us what is the vertical structure below the surface, and we can assess how thick this layer of waters that are warmer than 26 degrees are. And that is a good idea of the reservoir of heat that is available for us to feed the storm when the storm is passing. So that's really what it comes down to.
Well, Matthieu, what if two different hurricanes in two different ocean basins, they're both going over water that's 30 degrees Celsius, 86 Fahrenheit, but one has very shallow warm water and the other, the warm water is really deep. How can that make a difference in how the hurricane can develop or intensify?
So if the hurricane passes over the thick water of warm waters, the mixing associated with the storm will lead to a very small cooling. We expect when the storm passes, it mixes the ocean down to 100 meters typically, and we expect there is colder water below the surface. So when the storm passes, the induced mixing will lead to a cooling of the surface, and if the water cools at the surface, that is less heat that goes to the storm. However, if the layer of warm waters is very thick, the mixing is limited, and therefore the cooling is small. And if the surface water goes from very, very warm to just very warm, it will have a little impact on the storm. The storm might keep developing and becoming more intense. However, if the layer of warm surface waters is very thin and the cold water is very close to the surface, then when the storm passes, it mixes more easily with cold water, and the sea surface temperatures can decline significantly, enough to counter effect or dampen the intensification of the storm. That is why it's important to measure below the surface to have an estimate of this vertical structure.
Thank you for that clear explanation, Dr. Matthieu. I think that'll help our listeners understand there's more to understand than just the sea surface temperature. When we look at the basins right now, say the eastern Gulf of Mexico this week with impending Hurricane Helene, what do you see as far as sea surface temperatures? What do you see as far as oceanic heat content, maybe compared to normal, or how this can play a role this week with the developing hurricane?
So the situation in the Gulf of Mexico right now is we have a fairly extended loop current, and that detached recently a warm core eddy. So those are water masses typically associated with very large heat content, because there are Caribbean waters, very thick layers of warm waters near the surface. So that means that there is important reservoir of heat where the storm is going to evolve in the coming hours. And the sea surface temperatures are on the order of 30 degrees Celsius, if I'm not mistaken. They are about 1.5 degrees Celsius higher than typical in this season. But that's something that we've been observing in the past few hurricane seasons, that the temperatures are higher than they used to be. So that means that there is under the ocean, under the now Hurricane Helene, there is very warm waters that are sustaining the heat that feeds into the storm. There are really, really warm water at the surface of the ocean. So with the atmosphere that is conducive for development, because all these effects of the ocean are also dependent on the structure of the atmosphere has to be conducive for a storm to form or intensify. So with all conditions equal, the sea surface temperature are really high right now in the Gulf. Yeah.
Thanks, Matthieu, for that clear explanation. Before I pass it back to Tim, because we often get online questions, and we'll take a break at some point too to hear from our sponsors. One more question. I know a lot of your research focuses on oceanography and like dynamical oceanography. That word dynamical, what exactly does that mean as far as the physical science? What are you looking at when it comes to dynamics in the ocean?
So I'm interested as an oceanographer, I'm interested in regional processes, physical processes, that is ocean circulation, the ocean currents, how they evolve and how we can measure them, characterize them, and predict them. And that comes with the temperature and salinity structure of the ocean. I'm also interested in how these dynamical features can transport material and transport surface waters, like the Mississippi River plume, how the plume can extend inside the Gulf of Mexico under the influence of the loop current and the associated eddies that come with the loop current. There are cyclonic eddies that form along the current that can advect material and surface waters. And the Mississippi River plume has potentially an effect on storms as well, because it modifies the density structure at the surface of the ocean. So those are typically the physical processes that I'm interested in relevance with the hurricane problem.
Matthieu, so the Mississippi River plume, I'm imagining that's a lot of fresh water and generally cooler. How does that affect what's going on there, say, in the northern Gulf of Mexico?
So when there is a layer of fresh water, typically from a river plume, that creates a very big contrast in density at the surface of the ocean, with the fresh water being much less dense than the typical seawater below. And this contrast makes it harder for the storm to mix, which means that the mixing will not be as efficient as expected if it was only salt water all along. And this effect can be pronounced enough that usually in the ocean, 99% of the time, let's say, the density is driven by the temperature. The temperature dictates the density of the ocean. But when there is a river plume, a layer of fresh water at the surface that is with very, very fresh water, then the density can be dominated by this salinity signal, to the point that we can even have a temperature inversion, that the layer below this fresh water can be warmer than the water inside this surface layer of river waters. And when that happens, not only is the mixing difficult for the storm, but when it manages to mix, it mixes with warmer waters below. And that is bad news, because the storm can get intensified in spite of the mixing that it produces. So it's important to monitor those, and you cannot estimate the thickness of these fresh waters without sending a profiler, like I mentioned earlier.
Yeah, that's fascinating. It sounds like the ocean column can get very stratified or in layers like that and add a lot of complexity when you have a river plume like that. Matthieu, thank you so much for opening up, telling us a bit about your research and some of these insights. Tim, I wanted to pass it over to you to see if you had questions or if we have any questions coming in online yet.
A couple of thoughts, and one goes back to, and thank you, Hal, one goes back to when you're talking about the upwelling that comes behind a storm or with a storm. How, and I know there's no general rule for this, but how, like after a storm like Helene goes through the Eastern Gulf and goes over that loop current and churns up all the water, how long does it take that water to recover? So if another storm comes into the Gulf next week or in 2 weeks or 3 weeks, I know it depends on depth and everything, but how long does it take that Gulf to recover and get back to where it's got that heat content again?
It usually takes about 1 week. That's about the length scale. A few days, like 5 to 10 days, that's an order of magnitude about when the ocean will go back to what it was before the storm. So it's significant, but it's not that very long either.
That's interesting. That's quick, so if we see something in a week or two, we know that forget the upwelling.
Yeah, in 2 weeks, you would not bet on the ocean being much cooler. I wouldn't count on that.
That's really interesting. Well, what's the sail drones that you take out and you're doing this observation? How often are they out? What's the how widely spaced are they? What's the frequency of the observations from those?
So the sail drones are deployed during the hurricane season, like the gliders we are deploying from the OML, and we have also regional partners. There are many groups in the US that deploy ocean gliders. Now the sail drones, there are, I think, 12 of them deployed this season. They are deployed in the Caribbean region, in the Caribbean Sea and north of the Caribbean islands in the North Atlantic, and also in the Gulf of Mexico. There is one that is now under the path of the expected track of Helene, I believe. And there are also sail drones deployed along the southeastern U.S. coast.
So they're going all the time. Are these, and maybe I might have missed this at the beginning. I saw one that was in a pool and it was tethered. Are they all tethered, or are they completely remotely operated? How are those operated?
They are completely remotely operated. They are using winds to sail at the surface of the ocean, and they have solar panels to charge the batteries. Yeah, they are completely remotely maneuvered. Yeah.
How long can they stay out?
So they're designed to stay for the length of the hurricane season. So with the deployment I think the deployment started in June through July until November, I believe.
Wow, that's fascinating. That's fascinating. So I think when we look at it, we're going to get to the tropical update, and we'll get specific into Helene and what's going on there in just a second, what the interactions are going to be. But I think as we look at, hurricane forecasting, most of us talk about the atmosphere above. We don't talk about the ocean below. And I know you read the Hurricane Center's discussions, and they're all the deep oceanic heat content, et cetera. But so what portion of a hurricane's development is based on what's going on sea surface and below, you think, of a storm's development?
So I'm not an atmospheric scientist, so I don't have a full answer to that, and I might be biased to really focus on the ocean based on my background. But what we can say is that when the storms that are large and that are slow are more susceptible to interact with the ocean, and the ocean feedback will be more important. If a storm is small, the imprint on the ocean will be small, and therefore the feedback might be limited. And also, if a storm is fast moving, then the cooling that it leaves, by the time the ocean cools at the surface, the storm is already somewhere else, more or less. So that's also something to keep in mind.
That all makes perfect sense. All right, let's do a quick tropical update. Let me do that for you, and how we'll do your geotrek in just a second, and then we'll get to more questions, maybe specifically about this storm and how I'll jump back in. But let me see if I can do the Bill Reed here and show you what we're talking about in the tropics right now, and hopefully this will work. Like I say, this is the Bill Reed. You should be seeing my screen now, if that's correct. The 10 a.m. update is in on Helene, and it is now a hurricane. It was upgraded with 80 mile per hour winds as of the 10 a.m. advisory. It looks like the track hasn't changed much. You can see it's got the M for major hurricane right over the Florida coast tomorrow evening, about 7 o'clock tomorrow evening. So a little bit north of you. But I think more importantly, when you look at this map, look how almost the entire state of Florida is either under a tropical storm warning or a hurricane warning. Almost the entire state, including the entire East Coast, all the way down to the Keys. Just a small piece of the Western Panhandle, not under a tropical storm watch or hurricane, or a tropical storm warning or hurricane warning. That tells you the impact of this is significantly greater than that cone. And I think that's really important. And you also look at the wind field, the tropical storm force wind field, and notice it's all on the right side of the path, which is the Florida side of the path. So a lot of significance there, I think, as the storm moves off to the north. The models are relatively tightly clustered. I say that from a Texas point of view. If you're sitting in Tallahassee, you may not think that's as tightly clustered as we do on our side. From a Texas perspective, that's going to Florida, we're done, right? But if you're in Tallahassee or somewhere, Panama City or something, you're really paying close attention to what those models are saying. Satellite imagery, again, shows a very large storm developing. You can see the size of this thing is significant, not just the strength of it, expected to be significant, but the size. It's interacting with the Yucatan Peninsula right now, but it looks like the core of it just a little bit east of there. There's some recon. Notice the strongest winds, all the reds are on the right side. There's not much red on the left, a little bit right there near the tip of the Yucatan, but south side, it's not nearly as strong. So the reds are the stronger winds. And again, that's all on the Florida side, we'll call it. So how that's your side, and that's where the wind is going to be. That's where the surge is going to be, of course, as the storm moves northward. The intensity guidance, most of them take it at least to a Cat 2, some to a Cat 3. The official forecast does take it to a major hurricane before it reaches the Florida coast sometime tomorrow, probably tomorrow afternoon. But I say it and Florida coast. I mean, you look at that, there's a lot more to it than just it. It's not a dot. You look at that tropical storm force wind speed probabilities, and it's huge. The entire Florida peninsula is in that. Everybody, from Key West to Tallahassee and Jacksonville and Miami, and even Dr. Matt, you're in that tropical storm force wind field. So it's just really significant. And then the issue beyond that is it goes into South Georgia, and hurricane force winds go all the way up into the deep south of the southern U.S. Storm surge, and how we talk more about this in a second, but Tampa Bay area where you are, 4 to 7, 5 to 8 feet. That's the storm surge forecast, but up to the north of you, 6 to 10, 10 to 15. That's going to be a problem. How you were there last year with another storm, and you can talk about that significance. But notice even the east coast of Florida, storm surge problem. Georgia, South Carolina. So it's the size of the storm. Rainfall projections right now, basically the Big Bend of Florida, 8 to 12 inches of rain. You get down to where Howell is 4 to 6, but still a lot of rain, and that leads to flash flooding problems. There's your flash flood risk over the next few days. So that's the main storm out there, of course. There's a couple others, and let me refresh this to see if anything has changed. The storm out in the open Atlantic, an 80% chance over the next 7 days, and the one moving eastward, not a concern to anybody, but a 10 to 20%. And then interestingly, look what has come back. John is back in the Pacific. John made landfall, dumping huge amounts of rainfall on the Pacific coast of Mexico, causing significant landslides, probably mudslides. It moved back out over the ocean, and it's back to a tropical storm again with 35-knot winds, 45-mile-per-hour winds. And let's do this. Yeah, and expected to probably move right back in again. You can see bear with me while I bring this up because it just was updated. Goes right a little bit west of where it went in initially, but a little closer to Acapulco, where Hal, you visited not all that long ago. So that's kind of what I'm seeing out there right now. There's a lot going on. It's not a Bill Reed update, but it's a Tim update. It's what you're going to get. Hal, you can comment on a lot of that, but first do your GeoTrek update, then we'll get back to some more questions with Dr. Matt.
Tim, great tropical update there. I love that you focus so much on the impacts, and they're going to be widespread, as we know, throughout this region of the country. Well, a quick update from GeoTrek. With GeoTrek, we explore the world to tell stories about extreme weather and natural disaster not covered by the mainstream media. Check out our latest podcast focused on heavy rainfall below sea level, a focus on Hurricane Francine in New Orleans. I was in the Big Easy last week for a conference. I ended up hanging out with our close friend Chris Franklin, who's been a friend of NTWC for a long time. Tim, I got to tell you, Chris has told me for years it's so hard to forecast weather in New Orleans. I finally understood what he meant as I walked to his office in the French Quarter. To my right, there's gumbo. To my left, there's beignets and about 20 flavors of daiquiris. It was all I could do to just stay focused, get to the office and record this podcast. It was an interesting one too. He talked about a lot of the pumping system in New Orleans is very antiquated. It's actually 19th century technology. Sometimes they can't even find the parts for these old pumps that are 200 years old. Really interesting story about how Francine dumped 6 to 8 inches of rain really quickly and inundated a lot of metro New Orleans 2 weeks ago. You can hear that right there on the GeoTrek podcast. I also interviewed an engineer that does a lot with flood resiliency and just talked about how we can build better for places that flood frequently. So even if you're not in New Orleans, if you are in a flood-prone area, you're going to want to hear some of these insights on how you can actually build for frequent flooding where you're located. So that's the latest update from GeoTrek. We're on the ground this week in the path of Hurricane Helene, where we'll be doing social media clips, a lot of live broadcasts, and also recording audio for a future podcast.
I can't wait. Can't wait to see what you bring out of this. And it always a fascinating podcast. And I encourage our viewers and our listeners to check it out when you get a chance, because Great questions always, and great content always. So thanks, Dr. Howe, for that. We appreciate that. I want to thank our sponsors who make this program a reality each and every week. And we start with USAA. Thank you, USAA. My goodness, we couldn't do this without you. You've been with us from the very beginning with the National Tropical Weather Conference, with the Storm Science Network, and everything we've done over the last 15, 20 years. And we sincerely appreciate USAID's support through this. The South Padre Island Convention and Visitors Bureau, we will be at the beautiful Marriott Courtyard Hotel again in April of 2025, talking hurricanes, all things tropical. And we appreciate their support. We look forward to having all of you join us there in September when it's over, in April of 2025. We're glad to have you along. The Weather Company, supporters for a long time. Weather Boy, who does amazing things. Weather Boy bringing in college students with scholarships from all across the nation, really, from as far away as Hawaii, and bringing in college students, giving scholarships so they can come to the conference. We appreciate that. Weather Call, a new ad for last year, for 2024, and look forward to having them back in 2025 at the National Tropical Weather Conference. So thanks to all the sponsors who make this a possibility. Okay, well, let's get into maybe Helene specifics. And Dr. Matt, thanks for sitting through these updates, but I know that hopefully they have some interest to you as well. What do you see oceanographically as Helene goes over that loop current into the eastern Gulf of Mexico? What are you seeing out there in advance of this storm?
Well, like we mentioned earlier, the Helene is going to pass over the portion of the loop current in the coming hours that are, like I mentioned, very, very warm waters and a very thick layer of warm waters. So that's going to support the development of Helene, and as it is forecasted to keep intensifying, even rapidly intensifying. So the loop current is supporting that, and then next to the coast there is also there's a possibility of limited interaction with the river plumes, but that it seems that the storm will pass more to the east of the Mississippi River plume, so I don't expect strong interactions there. But the storm appears to be moving really, really fast, so there's a chance that it will feel only the sea surface temperature as it is right now. There will be little limited chance for negative feedback from a cooling ocean onto the storm, because it looks like it's going to be really fast. And the sea surface temperatures right now in the Gulf, like we mentioned, they are above average and they are very warm, and those are conducive for the development that is expected of Helene.
So is there anything oceanographically that would hinder this? It seems like everything is lined up for this to do what it needs to do, unfortunately.
Yeah, that's correct. I don't see any oceanic features that would lower the intensity, that would act against the intensification or the intensity of that storm.
Wow. I'll jump back in, bud.
Yeah, I had a question. We're getting into the time of the year where we start to see cold fronts approach a region. This isn't really a question as much for this week, but say getting into October, we see the sea surface temperature maps, a quick cool down along the coast in the northern and western Gulf Coast in October. Below the surface, often do we have quite a bit of heat when we get into the upcoming weeks and we're seeing the sea surface temperature drop near the shore? Or is there still some heat down below that can fuel these hurricanes once it's mixed?
So below the surface, the ocean is gonna keep the structure that we see now. So there is still, the Gulf of Mexico remains warm, more or less, beyond the hurricane season in the region. So the cold fronts will cool the waters next to on the continental shelf next to the coast, so that we can expect would have an impact on the storms before they make landfall. So they would meet colder waters, which should lower the amount of heat that feeds from the ocean to the storm prior to landfall. So that would be a positive impact when cold fronts start to happen in the northern Gulf.
Dr. Matthieu, I wanted to ask you also, when there's an impending hurricane, often the National Weather Service increases from 2 balloon launches to 4 balloon launches a day just to get more atmospheric data into the models. Do we see anything like that oceanographically? Are there additional models that are collected or additional data collected to go into the models when we see a week like this with an impending hurricane?
So the NOAA P3 airplanes, they drop airborne XBTs, and there are other type of floats that can be deployed ahead of a storm. So that allows us to allow the forecasters to have a better idea of the oceanic structure ahead of the storm. But besides these probes that are deployed by airplanes, it's complicated to send oceanic observations ahead of a storm, because it's complicated to go at sea and deploy. It takes time, it takes effort. So we're limited in what we can do as far as the ocean observations are concerned, which is why having unmanned systems like ocean gliders or sail drones that are sent ahead of time during the whole season so that they are ready in case something happens, that's our best strategy.
But I had a question as well. We see a lot of buoys out there in the ocean collecting data 365 days a year. How deep down do those data go? Is that just on the surface, or do they have any kind of instruments that hang below the buoys to collect subsurface data?
So it really depends on the type of moorings or buoys. If we're talking NTWC, they usually measure what's at the surface, like just above the surface and just below the surface. So that's limited information as far as the ocean is concerned, because it usually doesn't provide us with information on the vertical structure. Now, there are other types of moorings, oceanographic moorings, that measure the vertical structure of the ocean, but usually these oceanographic moorings they don't send data in near real time. They are for research purposes, and the data are not accessible in real time they're not accessible until we recover the moorings.
Yeah. Matthieu, last year, Hurricane Otis just absolutely blew up in the Pacific before striking the Acapulco area. I believe if I read the NHC report right, it went from upper level tropical storm to a Cat 5 hurricane in around 15 hours. Obviously, everything aligned atmospherically. I mean, are you familiar at all with what was happening out there oceanographically?
Well, that region is fairly different from the region I'm more familiar with, the Caribbean Sea, Gulf of Mexico, tropical Atlantic. And usually it's thick layers of warm waters. So it's not very clear what happened there and how the storm could intensify so fast, and the models miss that intensification so much. It was scary. Yeah.
We often hear about smaller hurricanes intensifying very rapidly. That's part of that's atmospheric control. But you mentioned before that these smaller hurricanes also aren't mixing as much as a large hurricane. I wonder if that also plays in. You know, if you have a really huge hurricane, it's probably going to mix more cooler water into the system, right?
Yeah, exactly. A larger storm will have a big footprint in the ocean with a large cooling at the surface that is expected to feed back onto the storm development.
Matthieu, with a storm like Helene coming in, if people want to say, okay, I want to see the best sea surface temperature maps in the path of the storm, or even oceanic heat content maps, how can people find this? Where would you direct people to find the latest resources online to understand like the track of the storm and what the oceanic heat content and sea surface temperatures will be in the region?
So there are various sources. I look at the NOAA resources. They have maps, global and regional maps of sea surface temperatures and the anomalies. So that is also striking, because the anomalies are usually in the warm colors, you know, the orange, red ones. That's striking. And there are other resources. There are this website on Tropical Tidbits. They have a lot of resources there also. I look at, you mentioned Brian McNulty, colleague here in Miami, is across the street from where I'm sitting right now. He has also a lot of resources. He gathered a lot of data from different sources, and that can be accessed on his website. Typically heat content, he has this fascinating time series of heat content, and also different maps of the heat content in the region.
Tim, I'm pretty sure Mark Sudduth just zoomed by me on a jet ski. I'm not 100% sure. It looked like a Duke Blue Devils hat from a couple thousand feet away. We might need to tell that guy to get to work.
He was placing an instrument out in the middle of the bay out there somewhere, right? That's funny. Well, let me flip the script a little bit. Let's go the other direction for a second, and we'll get close to the end here pretty soon. But we're talking about the impact of the ocean on hurricanes. Let's talk about the impact of hurricanes on the oceans, and whether it's marine life or salinity or mixing. What is it? I mean, there's got to be an impact when a significant storm goes over that beautiful ocean water. It has to impact everything about it, at least close to the surface. Would that be correct?
Yeah, that's correct. The mixing induced by hurricanes can be felt in the top 100 or 200 meters even. So that means cooling at the surface and the contrast in the upper ocean being much lighter or warmer than below. This contrast is erased by the storm or very, very dampened by the passage of the storm. And in terms of marine life, the mixing of waters from below the surface to the surface usually brings nutrient up to the surface, and we see an increase in biological activity in the surface following a storm. That is also quite fascinating. We also see intense transport of shelf waters that are strongly displaced by the storm because the mixing is limited, obviously, on the shelf. So the water moves horizontally rather than vertically, and there can be a lot of export of coastal waters into the ocean. And you can see in ocean colors all the sediments transported from the West Florida shelf. I remember when Irma passed over the West Florida shelf, there was a big displacement, and you could see the sediment being transported into the loop current and the Florida current and advected into the ocean. So those are major impact that hurricanes have on the ocean, not only the circulation, but also material transport and biological activity. Yes.
Which would suggest, I guess, like here, deep sea fishing is a big sport. It's a huge sport. And people have to go out to where the water's deep enough, cold enough. Here off the Texas coast, where they go to the 100 fathom curve, and where it drops off the end of the edge of the continental shelf. And that's where they fish because the water's deeper and colder. So I suppose after a storm, the blue marlin, the white marlin may come a little closer to the surface, and perhaps get a little closer to the coast just because the water's cooler and the nutrients come a little closer. Does that all make sense at all?
Yeah, I expect. Yeah, that's something we can probably expect. Yes, the displacement of the water on the shelf will depend on the orientation of the shelf with respect to the trajectory of the storm. So it can get a little tricky, but yeah, you can expect colder waters and nutrient-rich waters to be present in areas that they usually aren't.
I know something else you studied is pollution in the oceans and the transport of pollution wherever it's coming from land, from ships, from whatever. Does that have any impact on marine life, of course, but on hurricanes and where they're going? Does those big trash plumes that are out there have an impact?
I don't think that. I mean, however bad it is, the impact on hurricanes is really about the temperature and the heat that's available to feed the storm, and the pollution probably doesn't have an impact on that. It's the layers that are concerned are very thin, and so the overall density and temperature structure of the ocean will still remain the dominant factor. I don't expect the pollution to affect the hurricane problem, but they affect pretty much everything else, so they're still very, very important.
Break that down. Everything else. Talk about that. What everything else is.
Well, they impact the food chain, the health of the animals that live in our ocean. The Deepwater Horizon has had a very negative impact on the marine life in the whole Gulf of Mexico, all through the food chain that we are just measuring right now. So we are keeping we kept monitoring it since it happened in 2010, but some of the assessment is still ongoing, and there are still effects that we are discovering right now.
Wow, 14 years later, that's amazing.
Yeah.
Are there any other river plumes in North America that are significant besides the Mississippi? Are there any others that just really have a significant impact?
So North America, the Saint Laurent, but that's really far north. But in the Caribbean Sea, the Orinoco River and the Amazon River both have a very strong impact on the vertical structure of the upper ocean in the whole Eastern Caribbean and adjacent tropical Atlantic region. Yes, so they have this effect on the density structure that I mentioned earlier, with this what we call barrier layer, when there is a very salinity dominated layer at the surface due to the presence of river waters that can lead to temperature inversions below.
Interesting. And one other question that's come in, and we've talked about all the data that you're observing, that you're gathering, and maybe you touched on this a little while ago, but is that information going into our modeling for whether it's hurricanes or day-to-day weather? How is that information getting into the modeling, and how is it being used?
So yeah, all these observations, they are sent in real time to data centers, the same data centers that the operational models pick data from to ingest into their models. So the models that are used for hurricane forecasting, they are the NOAA Global Operational Model that takes all the available data on these data centers, data repository from satellite altimetry, satellite SST, and in situ observations, Argo float profiles, glider profiles, and other XBT profiles, and also the surface buoys, temperature measurements. And the models take the most recent data available. It's usually just a couple hours or maybe 3-4 hours after the data are collected. They're already available for the models to be ingested so that the ocean is as realistic as possible to use as initial conditions for the hurricane models that use coupled atmosphere and ocean model that are, yes, initialized by taking into account available observations on the ocean that I mentioned, but also on the atmospheric side.
So what do you think the future is? Where are we headed from this point, based on where we've come a long way in the last few years?
So your question related to modeling or observations or all of it?
All of it, yeah. It's all fascinating.
All of it. So we have this new method of collecting data. We've been doing it for 10 years now. So yeah, typically ocean gliders, and now the sail drones for the past few years. So I expect there will be a development of unmanned system to collect data where we need them, and that will feed critical information into the models that are used for our forecast. And then on the modeling side, we can expect improvement of the capacities of the models to represent what is going on when there is a hurricane, the better represent the air-sea interactions in a hurricane, because we have more data to tell modelers, hey, this is really what's happening when there is a hurricane. And so we can expect these models to really better represent these interactions, and therefore have a more reliable forecast in terms of now the tracks have improved, the forecasts of the tracks have improved in the past years, and we can expect with the improvement of models that the intensity forecast will also improve. In the near future.
Terrific information. You'll be pleased to know Dr. Peter Black is sending me maps of the ocean content right now in the Eastern Gulf of Mexico, saying, you guys got to see this. I'm sorry I can't share it with you here, but you got to see this. And we're in for it here in the next few days is what he's suggesting. Hal, jump back in as we get close to wrapping up the program.
Yeah, Dr. Matthieu, what would you say is like the biggest challenge right now to moving ahead with improving oceanographic models? What are some of the biggest challenges or obstacles that you face as you move forward?
So I would say one challenge is the fact that we are using global ocean models to estimate the state of the ocean, which is for operational purposes, it's great because you cover the whole planet, the whole oceans, and you can give information to everybody. But there is constraint in the refinement of the processes that you can represent in these models. So this is not the highest resolution grid you can have, and it's also the data assimilation that is performed is for global applications, and we could probably benefit from refined data assimilation, the way we ingest observations into models that might be fine-tuned for hurricane applications. I think that might lead to improvement, but it's very complicated to implement on an operational point of view. So that is that is something we hope to do better in the future.
Dr. Matthieu, could you see in the future there being like the focus on developing more like regional models, or like, areas that zoom in a little more as opposed to global models for, say, like just the Gulf of Mexico or portions of the Gulf of Mexico?
There are such models exist for various applications, but for hurricane, that's not how it's done yet. I think technically it's feasible, but it would require dedicated resources that is not it's difficult to have. So there are operational limitations in what we can do. So that's what we are using now.
Dr. Matthieu, one last question. We know in a hurricane, the seas can just be absolutely chaotic with huge waves coming from different directions. Like, is it well understood how that sea state changes that ocean-air interaction compared to just like where I'm at right now? You can see what it looks like here in Tampa, just the waves are very small. And that's usually what we see when we get out in the actual environment. These massive waves and the chaotic seas in a hurricane, is that well understood how that impacts the air-sea interaction, or not as much?
No, exactly, and that's a very good point. That refers to what I mentioned earlier, the fact that by measuring what's happening in very extreme conditions, thanks to unmanned systems like sail drones or gliders, we have a better picture and quantitative picture. We have actual numbers about what's going on at the air-sea interface. And yes, the waves, the magnitude of the waves, and how the waves impact the mixing and the circulation. And then another aspect that you mentioned is the chaotic aspect of the sea. It's hard to tell where is the ocean, where is the atmosphere when the waves are breaking. There are droplets everywhere. The droplets are a fast way to send heat from the ocean to the atmosphere. So the droplets are very important, and it's very, very important. The chaotic aspect is essential to the transfer of heat from the ocean to the atmosphere, and we still have a lot to learn about these processes.
Thank you, Dr. Matthieu. Tim, do we have any other questions, final questions that came in online?
Everybody's getting ready for the storm in Florida, I think, right now. So, which is good. I'm glad to see that. So, no, that's everything we have on this end. Dr. Matthieu, do you have any final thoughts? Anything you want to leave us with today, based on your research? What's something that's really important that you think we need to hear? We need to know as meteorologists, or just as people that care about the weather?
Well, I would reiterate that the ocean is very important to hurricanes, and the vertical structure of the ocean is essential if we want to understand the feedback and the air-sea interactions that take place under a hurricane. And it's essential to measure the vertical structure of the ocean, and like Hal just mentioned, what happens at the air-sea interface in these very extreme conditions.
Well, we appreciate your time and your input today. I just appreciate your research, and thanks for all you do at AOML and all you're doing over there. Thank you so much.
Thank you, Tim. Thank you, Alan. Thank you, Alex, for having me today.
Let me wrap, Hal, with you giving some final thoughts on where you are in Tampa Bay right now. What's your biggest concern as Helene sets its sights on Florida?
Yeah, Tim, I did a post last night. The three ways I think Helene could blindside us. Number one is the inland wind impact. Tallahassee, I-10 corridor and north all the way into Georgia, we could see some huge wind impacts. Also, the massive size of Helene. We're going to push this big surge, storm surge warnings all the way down to Charlotte Harbor. That's way down by Punta Gorda. So Venice, Siesta Keys, Sarasota, Tampa, St. Pete, all these areas, storm surge warnings. I think that could also blindside people. And number three, because the landfall looks to be farther west than recent hurricanes in Appalachia Bay, I'm concerned for people near Steinhatchee over to St. Mark's that said, oh yeah, we've just seen 2 hurricanes in 13 months, not a big surge. The slosh model from the National Hurricane Center says Appalachia Bay has the potential for the biggest storm surge in the U.S. So shifting this a little farther to the west, I'm concerned about people in these areas that got impacted by Idalia last year and Debbie last month that are going to let their guard down and say, oh, we're used to hurricanes. All of a sudden, this one comes in with a massive surge, maybe 10 to 15 feet high.
History is not the best teacher in many cases, and that's the case here. So thank you, Hal. I appreciate your time this morning, and thanks for keeping your feet dry and staying on land, and be safe down there. Keep us posted, and I'll email you my brother's address there. You can go by and check on his place for him.
Thanks, Tim. I appreciate it.
All right. Thanks to our sponsors who make this show a possibility each and every week. We want to thank them all. USAA, the South Padre Island Convention and Visitors Bureau. I can never say that. Visitors Bureau. The Weather Company, Weather Boy, and Weather Call. Thanks to Dr. Matthieu Le Henaff for being with us today. Thanks to Dr. Hal and Bill Reed. We'll hopefully see you next time as we come back for another episode of NTWC Plus. That's it for today. Have a great Wednesday and stay safe out there, please.